Hi everyone, welcome back. So in our previous lecture, we kicked off our intermediate DSA journey by focusing heavily on optimization. We took the count of factor problem, saw how a brute force approach could take an impossible 317 years and optimize it down to just 10 seconds using the square root approach. And then we used that exact logic to efficiently check if a number is a prime number or not. And after that, we already covered those internal topics, right? So now we are moving straight into part two of our introduction to problem solving. Today we are going to dive into some fundamental math problem regarding inclusive, exclusive boundaries, learn how to calculate the sum of n natural number and master how to count loop iteration. So we can accurately compare different algorithms. Let's pick up right where we left off. So today, our class we will start from a story. So there is a one boy, fourth class boy, who got a question. Find the value of like you just need to sum from 1 to 100, and you need to find the value. So it is very difficult to find the value, right? If you use brute force approach like 100 plus 99 plus 98 and blah 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 to 1, correct? So this is also your quiz one for you. Maybe you can also spend some time and answer it. I think somewhere on the screen you can see quiz one, and you can choose the option. I think you got some four option. Okay, so now I will tell you how this fourth class boy solved this problem. So what he did, he first just reverse the given n numbers, and then he summed with the given numbers. Like for example, okay, I will tell in this way. So first he just noted like 1 2 3 4 5 to 100, and then he just summed to 100 to reverse in a reverse order, 199 98 to 1. Okay, and he got a sum like you can say 2s is equals to 101 101 101. How he is getting 101? 100 plus 100, 100 plus 1 101, 99 plus 2 101, 98 plus 3 101 in same way, and last 100 plus 1 is equals to 101. So now you can like we can say 2s is equals to 100 into 101, correct? And we can say 2 is equals to 100 into 101 divided by 2, correct? So maybe you can do some observation here. Okay, so what observation you can do? You can see here 100 is a n. For example, 100 is a n. So you can say sum is equals to, I think here it should be s, not 2. So you can say sum is equals to 100. 100 means n multiply n plus 1 divided by 2, correct? You can say. So in the same way, what he did, so we can say if you want to find the sum of n natural number, what you can do, just sum of n plus n into n plus 1 divided by 2. So this is the we can say this is the formula if you want to calculate the sum of n natural numbers, n into n plus 1 divided by 2. This formula you may be using in the next class. Okay, now I will also tell you one thing about this fourth class boy. He's Gauss. I think you maybe heard this name somewhere. He's only the guy who developed this uh, method to calculate the sum of n natural number. Okay, now we will come to our second thing. So like we will go with some basic math properties. So here you have like, okay, somewhere if you get a square bracket with some a comma b, it means like a and b's are inclusive. and you need to return it with 2, 3, 4, 5. How? For example, here you got square inside a square bracket 2, 5. So you need to return it with 2, 3, 4, 5. In same way, if you got this bracket with a comma b, it means a and b are excluded. It means you need to exclude 2 and 5 and you need to return with just 3 and 4. So in same way, if you got 2 comma 5, so here it is a square bracket, then you need to return with like 2 is included, 2, 3, 4. 5 is not included because this is not the square bracket. In same way, here you can see 2 is not with the square bracket, then you need to exclude that, right? And 5 is with the square bracket, then you can return it with 3 and 4 comma 5, correct? Now, on your screen, you can see quiz 2 and quiz 3. Okay. So quiz 2 is you need to answer this. So you need to answer this 3 comma 10. So both are square bracket. Okay. Both are square bracket. I think somewhere on your screen you can see quiz 2. So now please spend some time and choose the correct option. Okay, now I will give the answer. So the answer is the answer is 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9 comma 10. Okay, so maybe someone asked why you added 3 or 10, because both are square bracket. So you need to include 3 and also 10. Now the next quiz. Maybe somewhere on your screen you can see quiz 3. Quiz 3 is A comma B with square bracket. Spend some time, choose the correct option. Okay, now I will tell you the solution. So here, we need to include in such a way A comma A plus 1, A plus 2 to till B. Okay, so we can say it should be B minus A plus 1. B minus A plus 1. Okay. Okay. I will also test it. Okay. So for example, if you check that quiz 2, okay, maybe now you can see B minus A comma B minus A plus 1, right? So now, like I will tell you how it will work. Okay. So now here you can see 10. 10 you can take as a B, and 3 you can take as a A. 10 minus 3 is 7 plus 1 is equals to 8. And here you can, if you calculate the value, 1, 2, 3, 4, 5, 6, 7, 8. Correct? So the correct answer is B minus A plus 1. Okay. Okay, now we will come to our next part. So next topic is what is iteration? So the next topic is what is iteration? So we can say number of times a loop run is called iteration. This is very basic topic. Okay, so maybe I think most of the person know what is iteration, what is prime number and all those things. Okay, but if you like, maybe few person don't know what is iteration, or maybe how we can calculate the sum of n natural number or something like that. So that's why I'm just starting from the scratch. Okay, so maybe from next class it will not bore you. I think some people get bored, like we already know, and why we I started from this topic. Okay, so maybe just spend some time. Maybe you can revise it. So for iteration, we can say if and like number of times a loop run is called iteration, correct? So in for this also we have quiz. Maybe you can see somewhere on the screen. Please spend some time and answer it. Quiz is, I guess, how many times will the blow loop run? Please spend some time and give the correct answer. Okay. Okay. So, okay. One more thing. Okay. Please don't direct answer it. Okay. Please use this technique. Okay. Inclusive M and exclusive brackets. So here you can say this for loop start. This for loop start from I is equals to 1 to I is less than is equals to N. I will go till less than is equals to N. So I will start from 1 and it will go till N. Correct? Correct? So we can say the answer will be N minus 1 plus 1. This it means it is N. We can say, right? Earlier only you saw that, right? P minus A plus 1 something. So we will use the same thing. N minus 1 plus 1. We can cut plus 1 minus 1 and we got N. Correct? Correct. Okay. So this is the correct answer. The correct answer is N. Now quiz to quiz number 5. Somewhere on the screen you can see the quiz. Please check it properly and tell the answer. How many iteration will be there in this loop? So loop started from 0 till 100. I would suggest you please use inclusive and exclusive brackets technique and count the correct iteration. Okay. Okay, now I will tell you the answer. So here there is one catch. Okay, there is one catch. I started from 0, not from 1. So we need to start our bracket with 0 till 100. So now we can say we will use the same method n minus 1 plus 1 last time which we used. So here if we use like 100 minus 0 plus 1, it should be 101. It should be 101. This is a little bit catch because we started from 0. Now the next quiz number 6. Okay, this is little bit tricky. So please check properly and then please answer it. Okay. How many iteration will be there in this loop? There are two for loop. One loop started from 1 to n and the other one started from 1 to m. So please give the correct answer. Okay, so I will tell you first about this for loop which started from 1 to n. Why? Okay, yeah. So here you can say if we use square technique, it will start from 1 to n and if same n minus 1 plus 1. So we got n iteration, correct? Same if you use for n m, you got m iteration, right? And now at the end, you need to just sum it n plus m. Why you sum? Why you added n plus m? And so because these for loop not like the other for loop not inside of the first one. Okay, so first this for loop complete and then we will start the other for loop. So maybe if you don't understand how it is n plus m, let's take an example. If Shivam went to market and buy 4 apple and 5 banana, then how many number of total fruits he bought? It should be 5 plus 9, correct? Here also, both for loop are separate. The first one N iteration one and the M iteration, both for loop are separate. So that's why the output is N plus M. Maybe someone, maybe if you guys, it's like N into M or something. So please take care. Okay. Now this is the last topic of today's lecture, how to compare two algos. So here we will have an example. Samir and Bhavin. Okay. We will take example of Samir and Bhavin. Okay, so now Samir and Bhavin were given a question to sort two arrays. Okay, and now Samir uh, and this guy Bhavin wrote one algo to sort two arrays. Okay, so Samir wrote algo 1 and Bhavesh written algo 2. Okay, just give me 1 minute, please. Yeah, so we can say this guy Samir written algo 1 and Bhavin written wrote algo 2. Now, I need to check which algo is better. So instead of that, like we can't check with code, right? So we will do one thing. We can just run these two algorithms with the same input and see how much time it takes, right? So what happened? Samir algo took around 15 seconds. Okay. Samir algo took around 15 seconds and Bhavesh algo took around 10 seconds. Okay. So now which algo is better? Can anyone guess who wins? Bhavin win, right? Because Bhavin algo took only 10 seconds. Cool. Mm, okay. Now there is some information we discovered. We discovered that Samir was running the algorithm on Windows XP. Okay, so what happened? Samir uh, ran the algorithm on Windows XP and and Bhavin uses MacBook M2. Okay, Bhavin is using a MacBook M2. So now it is a fair comparison to run the code? No, right? So let's say we give Samir MacBook M2 and then ask him to run the code. Okay. So now we give the MacBook M2 to Samir, ask him to run the same code in same algorithm in M2. And now what happened? Samir code run and it took around 7 seconds. It took around 7 seconds. And Bhavin code is still taking 10 seconds. So can we say that Samir code is better? Samir algorithm is better, right? Right? Because Samir algorithm is taking just 7 seconds and Bhavin algorithm is taking 10 seconds. But again, we discover one more thing. So what we discover, any guess? We discover that Samir is using C++, while Bhavin is using Python. Okay. What happened? Samir is using C++ and Bhavin is using Python. So system, like we can say one more thing here. So as Samir is using a C++ and Bhavin is using Python to write the code. Now we know Python is little bit slow than C++, right? So now we can we ask Bhavin to write the code in C++. So like now we ask Bhavin to write the code in C++. So what happened after that? Bhavin write the same algorithm in C++. So after that, the time came out to be 5 seconds and Samir still has 7 seconds. So when Samir write their code in C++ in a MacBook M2, it took 7 seconds. And Bhavin write the same algorithm in C++, same type of algorithm in C++, it took around 5 seconds. Okay. Okay. So now who wins? Samir is the same, language is same, system is same. So who wins now? Bhavin, right? So now a winner is Bhavin, correct? But there is one more catch actually. Samir is running the code on the top of volcano. Samir is maybe working or maybe running the code on the top of hot volcano. And Bhavin is sitting on Mount Everest. Bhavin is sitting on the Mount Everest after running the code. It gave 5 seconds. So when Bhavin is on Everest, it is taking 5 seconds. And Samir is on hot volcano, it is taking 7 seconds. Same algorithm, same code, same system, same language. So we can say, like, still we can't say which algorithm is best or which solution is best, right? And maybe we can say one more thing, like, or maybe we can say one more thing, like we know when there is a lot of heat around, system slow down, right? And when there is a cooling, proper cooling or too much cooling, system work better. So after we sent Samir to Mount Everest running the same code, it gave 5 seconds, and Bhavin was also 5 seconds. So then what happened? We asked Samir to went to Mount Everest, and it is taking 5 seconds. It is taking 5 seconds. And same, Bhavin also taking 5 seconds. So we can say, uh, like, no matter how much you control, or you cannot judge two algorithm based on the execution time. So basically, we can say in short, it is clear we cannot just do algorithm based on the execution time, right? Because it depends on a lot of factors, correct? Like maybe if you have any suggestion, you can post in the comment section. Okay, maybe someone suggests like, okay, no space or maybe something, but I will say iteration. If my code is taking less iteration, then it means my code is better because number of iteration will be same if you're using an operating system anywhere you are executing any language, right? So number of iteration do not change. Okay. So how my code slows? So my code slows when data grows, your code executes more iterations. Correct? Correct. So if you want to compare two algorithm, you need to check the iteration, not the algorithm taking time, maybe 15 seconds or 10 seconds or something. So maybe with this a comparison, you can say If you want to compare two algorithm, you need to use, you need to check number of iteration. All right. So that's all. Uh, all right, everyone. The topics we covered today, intervals, loop tracking, and counting of iteration, all are basic, okay, but they form a critical foundation for everything we do in competitive programming and DSA. In our very next class, we are going to level up significantly. We will be dividing maybe next session again in two parts, and we will be diving into big O notation algorithm, time complexity, space complexity, and how to avoid TLE error. TLE, maybe someone knows, like maybe few person know, time limit exceed. So I can say after our next class, you will completely understand how to read a problem, like how to read a problem constraint so that you never write a code that throw a TLE error again. You will know exactly how your code will behave before you even hit submit. These upcoming concepts are important for your interviews, so make sure you don't miss it. If you really liked today's video and found it helpful, please drop your thoughts in the comment section. I love reading your feedback. And don't forget to subscribe to the channel, share it with your friends, and stay consistent. I will be see you all in the next class. Thank you.